If I ask you, okay, if I ask you a question, so what is the process? So, you know, what will happen to the data in these information systems? So what are the steps of processing and communicating this data? Actually, what are the steps of generating this information? Can you just tell me? So I'll start from here, right? So process of information producing and communication. So if I write a heading like this, process of information producing and communication, the first thing I'll give you, that is data capturing. So can you tell me what will happen after that? The captured data, then what will happen? The data capturing, after data capturing, what will happen? Yes? Any idea? Okay, think that you capture data through keyboard, or you capture data through webcam, or you capture data through mouse or microphone. Then what will happen?
Process.
So as soon as you capture, are you going to process? So we discussed this last day also, but there's something called, so as soon as you capture, you convert into computer's format of the particular data. For an example, letter A for us is not the same for computer. Why? So we can see letter A in the keyboard. Is it same for the computer or different? Letter A for us here. This is letter A for us. Is it same for the similar for the computer, or is it different? So I asked one question only. You have to tell only one of these answers. Letter A for us and letter A for computer. Is it the same or different?
Different.
Different. How? So what is letter A
case,
for computer? So now you can see letter A here. So
exactly.
for keyboard, actually, it's a signal. For keyboard, it's a signal. You can press like Alt button and 65 in the numlock pad, and that is letter A. That is a signal for the computer, signal for the keyboard. And that keyboard will go to the, so then it will be going through the wires, and it will be then processed, and then actually processed by the VGA. And after that, it will come and display in the monitor. To monitor, again, it's a signal. What kind of signal it is? Yes, what kind of signal the letter A is? Okay, to see that, you can just increase the font size, and you can take a photo of this. Sorry?
I think.
Okay, I have captured this letter A. So this is my capturing, and let me zoom. This is now already 500% zoom. Edge width. Zoom this one. Okay, let's so let's open this letter A using some graphic application. So this is my capture. Okay. Well, let's open with the preview. You can see here, this is letter A. When I zoom this, when I increase this, what will happen? What is this?
Pixelate.
Yes?
Pixelate.
What you can see?
Pixels.
Pixels, dot, pixels. So if you analyze pixel, what is a pixel? A pixel is again a certain number with a color value, a certain number with a color value. That is arranged as a matrix. That is arranged as a matrix. Then we call this letter A. For monitor, that is a matrix. So did we discuss how this matrix forms previously? No.
No.
Okay, so you can just do this simple exercise. Can you see my screen now?
Yes, sir. Yes, sir.
You can do this simple exercise. Maybe you can use your book or you can use your computer, one of these. And I'm going to create, or if you have a square ruler book, you can use that. So I'm going to change the width to 3 and height also I'm going to change a little. Let's say it's 22. Okay, I have changed the width and height. Right, a very simple exercise to know about these pixels and how this matrix forms. Let's say this matrix is 1, 2, 3, 4, 5, 6, 7. 7 by 7 matrix. 1, 2, 3, 4, 5, 6, 7. 7 by 7 matrix. That means this is the matrix. Matrix means anyway, so certain number of digits in horizontal and vertical order. And in this horizontal and vertical order, let me make everything 0. 1, 2, 3, 4, 5, 6, 7. And down 1, 2, 3, 4, 5, 6, 7. Now you have 7 into 7 matrix. Okay. So let's have another matrix too. Just to know more about this and how these matrices work, I'm going to change this one also to 3. Now you have another matrix over there. So we can create that anyway. So in this matrix, what I'm going to do, I'm going to treat these digits as binary digits. Now I'm going to change the digits. Let's say this is 1, 1, 1, and this is 1 and 1, also 1. So let's make it 0, right? 0 here. 1, sorry, 0, 1, 1, and 1, 1. And let's make these digits all 1. Okay, let's say I have changed some digits. So now only 2 colors or 2 digits. Now you have 1 and 0 only. Let's say this 1 is a color, let's say 1 has color of red, and this is also in red, and this is also in red, and this is another red there. So do this and do. Okay, now so you can see, right, when you decrease the size, you can see the letter A. Can you see? Hello.
Yes, sir. Yes, sir.
Right. So this is how actually it happens. Right. This is how actually it happens. So small exercise or matrix operation to do for this. I'm going to multiply this by 2. I'm going to multiply this matrix by 2. Can you tell me the values after multiplication? When you multiply a matrix by integer, what will happen? When you multiply a matrix by integer, what will happen in mathematics?
Then it becomes 2A, sir.
So all the numbers need to be multiplied by a particular. Okay. All the digits must be multiplied by the same number. So I'm going to paste it over there, and this will become 2 now. Agree? Zeros remain 0 because why? When you multiply by
Because of
multiply
0,
by
0.
0, it's not changing the answer. Now it's 2. 2 is basically some other color. So that is how computer treat 2 is some other color. 2 is a number and that is some other color. This is how when you multiply by an integer, This is what happened when you multiply by an integer. Right, then, okay, I'm asking you to do something like this. Okay, so you have this matrix. And I'm going to write this matrix over there. And I'll subtract from this matrix. I'm going to subtract, oh, I'm going to add to this matrix. What I'm going to add is, I'm going to add another matrix. And that is it. This is the matrix I'm going to add to the particular matrix. Let's make all these things 0. Okay, what I'm going to add is, here I'll add -2. Here also -2. Here also -2. And here I have +2. And this matrix I'm going to add to the particular matrix here. So this is another one. Basically, this is another one. This 2 is blue. We already know this. 2 is blue. Let's say -2 is some, maybe some other color. Just treat like this. -2 is some other color. And I'm going to add this matrix. Now, can you tell me the value after adding these two matrices? What will happen when you have add two matrices? Yes?
So what is this regarding? Like,
Sorry?
about what?
Yes, sir. Even I didn't understand like this part for what is it?
Which
Sir?
part?
Like this part?
When you capture data, what will happen? So that is what I'm going to tell. When you capture data, computer will convert that to its own format. So in a screen,
Now
basically the matrix.
red means 1, blue means 2.
Sorry?
If it's red color, it's 1. Black, no, right?
Yeah. What is computer's format of images or computer's formats of
Binary.
any screen element is a pixel
Binary.
format. So what is a pixel format? If you analyze that pixel format, what is inside that? You have numbers. Really, you have numbers. These numbers, so when you send these numbers to these pixels, then it will lighten up. According to this lighten up effect, we see the characters or pictures or videos in the screen. So this is how screen elements are created. So that's what I want to give that's the idea that I want to give you. Right? The screen elements are created by just manipulating numbers, actually the matrices. So manipulating matrices only the screen elements are created. Understood or not? I'm going to tell how computer treat these things. We treat this as a letter A, but for computer, this is not letter A. It's a set of numbers and it is a matrix. That is for the computer.
Sir, for computer, there is binary. So that other part, sir?
2 is, yes, 2 is a binary. 2 is binary. How to write 2? Basically, 2 it will write as 1 0. 2 is 1 0.
Like, for the color also they change that format.
Yeah, 2 is 1 0, but that 1 0 you can't write in a single cell, no. So it will be 3D. The method 1 0 them they could have 1 0 means it's a 3D matrix. So this actually to make this less complex, that's why I use this decimal digit. But basically it's a 1 0. It's 1 0 means comes other way. Have you seen the 3D LED grids?
No, sir.
3D LED grids level
No, sir.
You have not seen 3D LED grids that are LED grid. So those are they are in the bulb. So here these are the LED grids.
Yeah.
Those are there in this bulb.
Yeah.
Whatever. This is a LED grid. So the monitor is basically a LED grid, nothing else. Here, if you have one color, so it will be shown like this. That is if you have one color. But if you have multi here, this is how it's shown in the LED grid. This is how letters are created in the computer screen. Same, but these LED grids you can visibly see the gaps, but in the computer screen, you can't see the gaps. So because it is micro level. So you have like around 1,000, 2,000 dots in the screen horizontally, around 1,500 or around 1,000 dots in vertically in the screen. So therefore you can't see the difference. But what will happen? So what will happen if you have another number? For an example, this is only on and off. If it is single color, on and off will be like this. If it is single color. But if it is multicolor, so there are RGB LEDs, right? If it is multicolor, that is another number basically. So pixel will get another number if it is multicolor, right? If it is RGB, RGB means another number. So that's the only difference. But anyway, this is how hardware treat these elements. And what will happen inside the processor is this. It will process. But what will happen inside the processor is this. Okay, so let's add these two. And so forget about computing. Add mathematically and tell me what's happening after that. So if you add a number to this.
What?
So add this matrix to this matrix. So may I know the other subjects that you are doing? What are the other subjects?
Technology and science technology.
ICT and ET.
Yep.
Okay, then I think you can do this. Can you add two matrices? So can you remember how to add two matrices? Can't. මතක නැද්ද?
Matrices.
No. Oh yes.
Nope.
So basically respective cells you have to add, right? This one should be added to this one. This one should be added to this one. So likewise, the respective values should be added. So here, this one should be added to this one, right? Next, in this one, the second one should be added to the second one here. Likewise, the respective digits should be added. So when you, okay, I'll continue the process. If you add the respective digits, what will happen? It will generate something like this and something like this. So then you can see, if I recolor this, we have just, imagination is we just taken this as a concept, right? Concept එකක් විදිහට විතරයි මම කිව්වේ මේ 2 is blue, 1 is red කියලා. ඒක අදාළ it depends on the particular chip, microchip and the circuit and the LED set, right? So some LEDs, so it can be 1 is red, 2 is green, 3 is blue. Or there are some advanced LEDs having more colors. Right? You can use more color combinations. For an example, have you seen this LED, multicolor LED bulbs? Multicolor LED light. Have you seen this?
Yes, sir.
Right, that can be here. This is also multicolor LED light. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here, these are the numbers. So by changing the numbers in the remote, you can change the color of the bulb, right? So that is it based on the particular mechanism, right? We can't tell exactly 2 is blue, red, 1 is red. I have taken just example, right? Okay, so then what will happen? You can see after adding, you will get this one. After adding these two, you'll get this one. So which looks like letter H. So this is what happening in the computer, right? It will treat everything as matrices. It will think everything as a matrices and do mathematical processing over that. Okay, anyway, so after data capturing, sorry?
Screen resolution, like,
yeah, screen resolution is actually
20 into 1080 means that's the maximum pixels.
Yeah, that is the maximum pixel number of pixels that you can divide the in the stream. So image resolution and screen resolution. Stream resolution is, okay, let's say stream resolution means
million.
So what is screen resolution? This is extra thing. Screen resolution means number of horizontal pixels into number of vertical pixels. So that is screen resolution. This is extra, right? And what is image resolution? When you take a photo from a camera, again, number of horizontal pixels into number of vertical pixels. So if you get a photo from, if you got a photo and a photo has 400 example, if photo has 400 horizontal pixels and 4,000 horizontal pixels and 3,000 vertical pixels, what is the total? What is the total number of pixels? 4,000 into 3,000?
12 million.
12 million. That is called 12 megapixel. Right? Okay, this is how the things happen in the computer. So it is a computer or digital photography or photo in a camera or whatever. So what is there is basically this. So if you take an image, right, any kind of image, let's take image on, and I'll take this one. I'm going to open this. Right, we will think this as a photo or image or maybe actual person is there, but nothing is there. So basically for computer, it's a number, none other than that. So let's see, let's open this using, so I'm going to open a picture using Photoshop or photo editing software. Okay, now you can see. Okay, you can see the picture. So let me zoom this and okay, let me zoom this. Now still you can see the picture, but when you zoom, and now you can see the, now you can see the pixels. Can you? Hello?
Yes, sir.
Can you see the pixels? Okay. So then if I go to 1 pixel, let's zoom more.
Yes, sir.
Okay. Let me zoom this more. And I'm going to take 1 pixel. Let's take this pixel. I'm going to right click on that pixel and copy the colors hexacode. Here you can see copies the colors hexacode. And let's come back to this. I'm going to paste it here. So you can see it's a number. But it is represented in hexadecimal, right? So what is the respective binary value? Can you tell the respective binary value of this pixel?
Yes, I have to divide, right? What do you call it?
No.
Convert this into binary.
No need to divide. So this is hexa.
Okay, convert into binary.
Yeah, convert into binary. This is hexa. So if you have a hexa in binary, it's easy to write binary. 7 means 0, 1, 1, 1. 2 means 0, 0, 1, 0. 5 means 0, 1, 0, 1. And 3 means 0, 0, 1, 1. 4 means 0, 1, 0, 0. And 1 means 0, 0, 0, 1. This is the respective binary. So that is stored in that single square. Right? That is stored in that single square. Actually, this portion is showing what is the intensity of red. The second portion is showing what is the intensity of green. The third portion showing what is the intensity of blue. Right. This is how it is shown in, this is how the value is divided to the primary colors, red, green, and blue values. Okay, let's change this pixel value to full red. Sorry, full red. I'm going to copy this. I'm going to change this pixel value to full red. All bits are red. And then no green. So all these green bits, I'm going to make it 0. No greens. And okay, have some blue. Some.
So you will leave space in the red now.
Sorry?
You didn't leave space in the red, no?
Can use, but
1 1 1 1.
so anyway, no spaces are there. For readability only, I'm using spaces, right? No spaces are there. Okay, now can you tell me the number in hexa? What is the
This
number in hexa? 1111 means?
It's 15.
15. That is FF 00, then 8, 8. So this is the value now. So this is the new value, right? FF00. This is the new binary value. FF0088. Okay, let's go.
Hexadecimal value.
Yeah, hexadecimal value. Now let's go and change this value to. I'm going to use the brush, and okay, I'm going to use the brush, and I'll reduce the size of brush to 1 pixel, just 1 pixel. I need only 1 pixel, and I need a hard brush color which can color 1 pixel. And now the color that I'm going to use is, what is the color? FF0088, right? That color is this here, FF0088. You can see the color, right? It has more here. These are the decimal values. 255 red. It has 136 blue. If I reduce the blue, so let's reduce the blue to 00, then it is only red, pure red. If I add more green, let's say add 44 green and 00 blue. Now this is the color. It's like getting orange, right? Let's add more green. Now it's getting yellow. Red FF, green FF. So likewise, I can change the pixel color, pixel number. So okay, let's use the number that we thought, 88. And I'm going to change that number. And then I'm going to fill this pixel with that number. Okay. Now let's reduce, but you can't see that because it's a very small dot, right? You can't see the change. But anyway, if you zoom, that change is there in your picture. Okay, so understand what's happening in the computer really, right? That is what I really need. So everything is treated as numbers in its own format. So in string elements are given as pixels. Those are also numbers. And sound elements are also treated as numbers. Letters are also treated as numbers. All these things are numbers to the computer. And ultimately, it's a binary. Ultimately, right? But it is represented using different schemes. It can be decimal, hexadecimal. So because ease of use, it's used in hexa and maybe decimal numbers. But actually, what is there is a binary. Okay, so let's change this to pure binary. If I want to change this to pure binary, I can go to image, adjustment, and I can make this threshold. Right, this is not Photoshop lesson. Okay, I have thresholded this to 2 levels. Let's say 2 levels, only 1 level. 2 levels, right? 2 levels. Let's threshold it to 2 levels. Now, this is what you can see. Nothing is there, no? Hello?
Yes, sir.
No, sir.
Nothing. You cannot see anything because 2 levels, you can't see this. That's not enough. But if you have multiple levels, let's adjust this to multiple threshold levels. Adjustment to threshold level, and I'm going to add multiple threshold levels. So like this, like this. Now you can see something.
Yeah.
Yes, sir.
Now you can see something in the screen. But now if I go to this and if I try to see a pixel value, okay, now if I try to see the pixel value, you can see it's either black or white. Yes, it's 1 or 0.
Black or white.
Yes, it's 1 or 0. Basically 0 is black and 1 is white. So these are the lighten up pixel and these are the turn off pixels. So this is, but that in initial days, earlier days, information represented by using two values like this. But you know what? So it's not really perfect. No, it's giving some idea. Earlier days in film, in and maybe image in industry or the capturing. So these two values were only there. Monitors were capable of showing only two values, either on or off. Right? Either on or off. That is not enough. That's why now this is a 2D. This is 2D matrix. Make a 2D. Make it in 1 0 with only ones and zeros. But when you have multiple values, large numbers, let me pick the value and show you right click. And I'm going to pick the copy colors hex code, and you can see the value over there. So that is 0. And right click here, copy colors hex code, and nothing is there. That is here, it's white, only white and black, only white and black, only two colors. This is how the image is represented earlier days. I think you got the idea, clear idea about what is happening after capturing this data, right? So if webcam take your picture, what will happen? It will be converted to computer's own format. If
So
keyboard,
you get all those data so fast,
sorry,
like so much data, right, to capture, to process.
yes, there's a lot. So millions of pixels. You can see if you take this one, how many pixels? 12 million pixels. If you take this kind of image, 4,000 into 3,000 image, 12 million pixels, you have to assign numbers to all 12 million pixels. And you know, if it is a hexa number, it has, then hexa number, it has how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, another 12, 24. So 12 million into 24. Binary changes. Binary is got 12 වැඩි කරන්න ඕන 24. එතකොට එනවා අපිට 12 20න් අපි වැඩි කරමු 12 into 20 is 24 250 240 එතකොට 240 million pixels එතකොට binary changes වෙන්න ඕන million 240ක් to show this image in the screen මේ image එක screen එකේ පෙන්වන්න 12 megapixel image එකක් photo එකක් ඔයාගේ monitor එකේ පෙන්වන්න 240 million pixels change 240 million binary changes process කරන්න million 240ක් හැබැයි ඔයාගේ computer එකට පුළුවන්නේ it is like basically more than 1 gigahertz 1 gigahertz කියන්නේ කොච්චරද 1 hertz means 1 cycle 1 kilohertz means 1000 cycles 1 megahertz means million cycles 1 gigahertz means billion cycles. ඉතින් අතන තියෙන්නේ processors හදන්න මේ තියෙන්නේ 240යිනේ million 240 හැබැයි 1 gigahertz processor එකක් තිබ්බත් එයාට පුළුවන් billion එකක් process කරන්න එකපාර. ඒ වගේ binary actions billion එකකට ළඟ process කරන්න පුළුවන්. So that is capable enough to show this in 1 second. Right? තප්පරෙන් පෙන්වන්න පුළුවන්. තප්පරෙන් ඒ photo එක පෙන්වන්න පුළුවන් because computer processor is capable of enough of doing billions of tasks per second. So this is අර මේ වගේ task එකක් එයාට කජු කනවා වගේ වැඩක්. තප්පරෙන් පෙන්වන්න පුළුවන්. Understood the depth of the subject? So this is not there in the first lesson, right? But just understand the depth of the subject, right? Okay. Anything else? Any questions?
No.
Did you understand or you need more explanation?
Understood, sir.
Okay. So then data capturing, after data capturing, what will happen? So it is called data representation. Data representation means presenting it in its own format. Presenting this in its own format, that is called data representation. After data capturing, it has data representation. After that only, it has data processing. Data capturing, data representation, and then data processing. And anything else? Anything else happening here? Only capturing, representation, processing. Is that all?
Storage.
Yes. Memorizing and storage. And then that's the next complex thing. So when it comes to these pixels, it can be remembered at this way. Okay. But how to keep these things in your hard disk? How to keep these values in your hard disk? So that is the next challenge. Right? So that is not easy. That is not easy to keep this thing in your hard disk. It is not easy to keep this thing in a CD. But it has a mechanism. How? How it is stored in a CD? How it is stored in a CD? Any idea? Yes? If not, tell no. Then I can explain. How it is stored in a CD. Ashan? Yashin, sorry.
No, sir.
No idea. Okay. So basically what will happen in a CD, data storing in a CD. Just see what's happening over there.
Sir.
Just give me a second, right? Okay, let's see what's happening in a CD. Here you can see, so this is like, this is how it looks like when you see using a microscope. This is how it looks like when you see this using a microscope. These areas are called pits and lands. So you know,
Yes,
there's something called CD burning. CD burning. CD burning. Here, what will happen is there's a laser beam. This laser beam is sending this to the plastic transparent layer to this reflective aluminum layer. Basically, it's aluminum, platinum, or gold.